In this video, we're going to talk about 1.3 Objective 5, where we prove and use trigonometric identities and other concepts. So let's prove that secant theta is equal to 1 over cosine theta. Cosine theta is x over r. We have a triangle here, x, y, r. Cosine is adjacent over hypotenuse. Secant theta is r over x, which is hypotenuse over adjacent. So 1 over x over r. Secant is the reciprocal of x over r. So 1 over cosine theta is secant theta. 1 over is the way you can do reciprocal in math. So if we take the reciprocal of r over x, it's x over r. Hopefully that made sense. Prove that the following equation is an identity. Sine over cosecant plus cosine over secant is equal to 1. So we want to say that this is sine times 1 over cosecant is going to be sine squared, plus cosine times 1 over secant is going to be cosine squared, and sine squared plus cosine squared equals 1 is an identity. Prove that secant of pi over 2 minus theta is equal to cosecant. It's a co-function identity there. So using complementary angle theorem, that if we have alpha, beta, and 90 degrees here, that cosine alpha is equal to sine beta, like that. And beta is pi over 2 minus alpha is really what beta is. Then we can say that 1 over cosine alpha is equal to 1 over sine beta. And so that means that beta is equal to theta here. So what we're going to use, this is my beta, because this whole thing here is my alpha. So, and substitute here, the alpha is pi over 2 minus theta, and beta is theta, into the equation 1 over cosine alpha equals 1 over sine beta. And you're going to get 1 over cosine of the quantity pi over 2 minus theta is equal to 1 over sine theta. 1 over sine theta is cosecant theta, and your left-hand side is secant of pi over 2 minus theta, and we're done. Normally, we don't work on both sides like that to establish an identity, but it works in this case, so let's just go ahead and do what they told us to do. Use the given figure below to prove the law of sines, that sine of angle A divided by side A equals sine of angle B over side B equals sine of angle C over side C. And let H be the altitude from vertex B to side B that's drawn in the picture here. Determine an expression for H in terms of angle A and the length side C. So that's going to be C times the sine of angle A. And now determine the height in terms of uh, angle C inside A. So that's going to be A sine of angle C. And when we set those equal to each other and divide them out, that's going to be sine of angle A over A is equal to sine of angle C over C. And now we're going to draw our height from angle C to side C. So that's going to be H2 here, is going to be, in terms of A, side A and angle B is going to be A sine of B. And in terms of angle A and side B is going to be B sine of A. And so we have sine of A over A is equal to sine of B over B. But we already know sine of A over A is equal to sine of C over C as well. So all of these relationships here have to equal one another. All right, let's prove that the area of the sector of a circle of radius r associated with a central angle theta measured in radians is A equals 1/2 r squared theta. Area of a circle measured in terms of its radius is pi r squared. Angle of the measure of the circle in radians is 2 pi. If we go all the way around the circle, that central angle is 2 pi. Let A be the area of the sector of a circle with radius r associated with a central angle theta. The ratio of the angle measured of the sector to the angle measure of the circle. So what part of the circle, what fractional part of the circle is it? Is it's going to be theta over 2 pi, which is equal to the ratio of the area of the sector of the circle here, A over pi r squared, like that. And so that's going to give us the formula here. Area is 1/2 r squared theta when we put everything together. When we set the two ratios here equal, and multiply here pi r squared, so you can see the step. A equals 1/2 r squared theta. That's where the formula is coming from. All right, let's verify the identity that 1 minus cosine of t over sine of t is equal to sine of t over 1 plus cosine of t. So we're going to first multiply by 1 plus sine of 1 plus cosine of t over 1 plus cosine of t. And we're going to get 1 minus cosine squared t over sine of t plus sine of t cosine of t. That gives us a sine squared t because of a Pythagorean identity in the top over sine of t plus sine of t cosine of t. Factor out the sine of t and cancel, and we get equal to our right-hand side of sine of t over 1 plus cosine of t. So our second step here was apply a Pythagorean identity to simplify the numerator, and then factor out and divide the common factor of sine of t, numerator and denominator, to get it equal to the right-hand side. I would have left it factored. I wouldn't have distributed, but I'm just writing down the steps as they have them in my labs here. So I would have done 1 minus cosine squared of t over sine of t times 1 plus cosine of t equals 1 equals sine of t over 1 plus cosine of t. I would have made this sine squared of t over sine of t times 1 plus cosine of t. And I would have canceled here. And I would have gotten sine of t over 1 plus cosine of t is equal to sine of t over 1 plus cosine of t, like that. And that's it for this video. We'll come back next time and we will talk about 1.3 Objective 6. See you for the next video.